Welcome to this Sailing Weather Educast from U.S. Sailing and Sailing Weather Service. I'm meteorologist Matt Sanders, and in this Educast we're going to investigate convergence cloud lines. But as always, remember this is an educational lesson, not a forecast, so always check out that actual National Weather Service forecast before heading out on the water. Now, in other lessons, we've talked about the winds associated with individual clouds that you might encounter over part of a race course or while out cruising. But in this lesson, we're going to look at a cloud formation called a convergence cloud line that is made up of many individual clouds and can exist over many, many miles. And in this image, you can see an example of a convergence cloud line made up of low-level cumulus clouds. But what's causing this cloud line to form? Well, it's usually as simple as winds that converge nearly head-on. And when these winds converge, they're forced to go somewhere, so they rise, and as we've discussed in other educasts, this rising air often results in clouds, as you can see here in this diagram. So, the important point to remember is that a convergence cloud line will exist more or less perpendicular to the wind directions, which means if you sail across the cloud line or it moves over your location, expect the wind to shift abruptly to a new direction that is greater than 90 degrees and often closer to 180 degree wind shift. Also, the wind speed will ease as you sail toward the cloud line to the point where it could become nearly calm under the clouds, and then the winds will increase as you sail away from the cloud line. But it's important to point out that you will not know the exact wind speed on the side of the cloud line opposite to your current location, and that's because the wind speed may not be equal on either side of the cloud line. And this can be seen in this diagram. We start out with a sailboat in a 20-knot easterly wind, but as the sailor moves closer to the cloud line, we see wind speeds ease, in this case down to about 10 knots. And then as the sailboat gets closer to the clouds, in fact, it goes underneath the cloud line, winds become very light to calm. And finally, sailing away from the cloud line, the wind shifts to a westerly direction and increases first to 5 knots and then to 10 knots. But notice that the winds on either side of the cloud line are not equal. And here's a good example of a convergence cloud line off Cape Cod, Massachusetts. You can see the clouds in nearly a straight line extending for quite a distance. And let's go over how this convergence cloud line developed. It's specific to this location, but the conditions it represents can happen anywhere. So, the photo was taken in the location of the red star, you can see here on the map, and on this day there was a south-southwesterly onshore wind of about 20 knots. And the flow found its way into this bay, which is off of Hyannis, Mass, where the terrain caused it to veer around to the north-northwest and ease to about 10 knots. And this flow converged with the south-southwesterly flow to cause the convergence cloud line. So, what's important to recognize from this example is that you can see winds on either side of the cloud line are nearly perpendicular, and the speeds happen to be stronger on one side versus the other. And that's going to do it for this lesson on convergence cloud line. Remember, they can happen just about anywhere, so keep an eye out for them. And in the next lesson, we are going to take a look at a similar but different feature called confluent cloud lines. So I'm meteorologist Matt Sanders, and I hope you enjoyed this Educast.